What are even functions? What are odd functions? And do all functions fall into these two categories? Well, first of all, let's explore what an even function is. An even function is symmetric with respect to the y-axis. In other words, we're going to treat this y-axis as if it was a mirror, and we want to reflect this graph in the mirror of the y-axis. So I want you to look at this. Something is even if f of negative x equals f of x. For a lot of people, you're going, what does that mean? Well, let's take this x value of 1 and you get a negative 3. This says if you take f of negative 1, you're still going to get a negative 3. So that means if I plot the point negative 1, negative 3, it's going to be reflected in that y-axis. So again, we take the x, we take the opposite of it, which is negative 2, but we keep the same y value. Remember, f of x is the same as y. So again, it would be reflected. I want you to see that it's equal distance away from the y-axis. So here we take the opposite, but we keep the same y value. So negative 3, positive 5. And so for any xy point on the graph, you're going to get the reflection if you take the opposite of x but keep the same y. That's an even function. In fact, this is a graph of x squared. And I think that's why they call it an even function, because you have even exponents. Let's look at the odd function. Okay, so this says take the opposite of your x value and you're going to get the opposite of the y value. So we're going to take 1 and make it negative 1, and we're going to take the opposite of the y value. Going to take the opposite of the x value and the opposite of the y value. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. And if we connect those dots, we have an odd function. Now, if I read, it says it's symmetric with respect to the origin. It's kind of hard to hold up a mirror to a point. So I want you to think about what happens is that it gets reflected over the y-axis, and then, so it's a two-step process, reflect over the y-axis, and then we're going to flip it over the x-axis. So it's kind of flip over here and then flip down here, and we have an odd function. And again, in fact, this is a graph of the cubic function. I'm just going to erase this so you can see what we have left. And again, I believe they call it odd because you end up with odd exponents. So it's really easy to tell from a graph if it's even or odd, but what we want to do is the algebra. So you're going to have a few problems that ask you to determine if the functions are even, odd, or neither. They cannot fall into more than one category. They're either even, they're odd, or neither. And most functions are neither. So how do we do that? We take that definition. We go, if it's even, f of negative x will give you what you started out with. That would be even. If it's odd, you take negative x and you end up with the opposite of what you started out with. You get odd. And if neither one of those happens, then it's neither. So both ways, you're going to replace x with negative x. So we have f of negative x, going to come back here, negative x cubed, use those parentheses. Alright, so what happens when you cube a negative? It's negative. Negative times negative is positive. So look at what you started out with, look at what you have. Are they indeed, let's see, is it the same? No, so it's not even. Is it the opposite? Well, what is the opposite of x cubed minus 6x? The opposite is if I put a negative and distribute it. Look at there. So it is the opposite, so this function is odd. And that doesn't really surprise me because we had an odd exponent there and an odd exponent there. So after I said that, what's your prediction here? We have two even exponents. I'm going to predict that it's even. So again, the process is to replace x with negative x. Please put it in parentheses. Okay, so we're going to raise a negative to the fourth power. That's going to be positive. We're going to raise a negative to the second power, so that's positive. Oops, don't know where that came from. Okay, so then I look and I go, is this the same as that? Yes, it is. So it's even. So you're probably going to say, it's got to be neither. Probably so, because look, we have an even exponent and an exponent and a constant, believe it or not, is x to the 0, which is even. But we've got even and odd. So our prediction is neither, but let's go through the algebra like you're supposed to and replace x with negative x. Okay, again, we square something negative, we get positive. That's negative, and of course that stays the same. So, is it the same as our original function? No, because of this negative sign, so it's not even. Is it the opposite? Well, let's see. What's the opposite of that? Again, if I distribute the negative, are these the same? No. So it's not even, it's not odd, so of course our prediction holds. So really easy to tell if something's even, odd, or neither by either looking at a graph, or the algebraic way is wherever there's an x, replace it with negative x, and then make your determination.